Welcome back to volume. All right, let's go on with our measurements. First, we're going to talk about volume. Do you drink milk or orange juice with a breakfast? If so, how much do you have? You probably don't measure it out. You just pour it into a glass. You decide when to stop pouring by observing the amount of space it fills up in the glass. Volume is the amount of space an object takes up. Volumes of liquids. To measure the amount of liquid, scientists use a unit known as the liter. You have probably seen 1 liter and 2 liter bottles of beverages at the grocery store. You can measure smaller liquid volumes using milliliters. There are 1,000 milliliters in a liter. To measure the volume of a liquid, just pour it into a container with markings that show the volume. Scientists commonly use a graduated cylinder to measure liquid volumes. The graduated cylinder in figure 4 is marked off in 1 milliliter segments. Notice the top surface of the water in the graduated cylinder is curved. The curve is called the meniscus. To determine the volume of water, you should read the milliliter markings at the bottom of the curve. So look at this up here. This is the meniscus. You will see that it's the curve. We measure at the bottom of it, and we get 45 milliliters in this case. Volume of rectangular solids. How can you determine the volume of a solid object such as a cereal box? The unit you would use is the cubic centimeter. A cubic centimeter is equal to the volume of a cube that measures 1 centimeter on each side. This is about the size of a sugar cube. 1 cubic centimeter is exactly equal to 1 milliliter. Please note that you're going to be using that in this class and in rhetoric. 1 cubic centimeter is exactly equal to 1 milliliter. For solids with larger volumes, scientists use the SI unit known as the cubic meter. A cubic meter is also equal to the volume of a cube that measures 1 meter on each side. You can calculate the volume of a rectangular solid using this formula. Volume equals length times width times height. Suppose the cereal box is 20 centimeters long, 6 centimeters wide, and 25 centimeters high. The volume of the box is 20 centimeters times 6 centimeters times 25 centimeters, which equals 3,000 centimeters cubed. You've done this many times in math class. Okay. Notice that when you calculate volume, in addition to multiplying the numbers, you also multiply the units. So we had centimeters 3 times. That's why it is centimeters cubed. Okay, let's go on to volume of irregular solids. Suppose you want to measure the volume of a rock. Because of its irregular shape, you can't measure a rock's length, width, or height. How then can you find its volume? One method is to immerse the object in water and measure the water level rises. This method is shown in figure 4. Okay, density. Can you let's go back and look at figure 4. Hold on. Okay, measuring irregular solids. First, you take a graduated cylinder. You record the volume. So this time it's 35 milliliters. You carefully put the irregular solid in because it can break the graduated cylinder because it's usually glass. Then you look and see, oh, the water increased to 41 milliliters. Then you're going to subtract 35 milliliters from 41 milliliters, and you're going to get the volume is 6 milliliters. Okay, that's how we calculate the volume. Density. As you see in figure 5, 2 objects of the same size can have different masses. This is because different materials have different densities. Densities measure how much mass is contained in a given volume. To calculate the density of an object, divide its mass by its volume. Okay? Units of density. Because density is actually made up of 2 other measurements, mass and volume. An object's density is expressed as a combination of 2 units. 2 common units of density are grams per cubic centimeter or grams per milliliter. Remember, we said 1 cubic centimeter is the same as 1 milliliter. I told you that would be important, so just note that. In the case of a numerator, in each case, the numerator is the measure of a mass, while the denominator is the measure of the volume. So let's look at this calculating density. Suppose that a metal object has a mass of 57 grams and a volume of 21 centimeters cubed. To calculate the density, remember, density equals mass divided by volume. So you are going to take the, You are going to take the mass divided by volume, 57 grams divided by 21 centimeters cubed, to get 2.7 grams per centimeter cubed. You will have to do this practice problems as part of your homework. Density of common substances. The table in figure 6 lists the densities of some common substances. The density of a substance is the same for all samples of that substance. For example, all samples of pure gold, no matter how large or small, have a density of 19.3 grams per centimeter cubed. Once you know an object's density, you can determine whether or not the object will float in a given liquid. An object will float if it is less dense than the surrounding liquid. For example, the density of water is 1 gram per centimeter cubed. A piece of wood with a density of 0.8 grams per centimeter cubed will float in water. A ring made of pure silver, which has a density of 10.5 grams per centimeter cubed, will sink. Okay, let's look at this. Will an object with a density of 0.7 grams per centimeter cubed float or sink in water? Take a minute to think about that. Pause if you need to. So water has a density of 1.0, which is greater than this object, and so the object will sink. Time. The crowd cheers wildly as you near the finish line. You push your legs to run even faster in the final moments of the race. From the corner of your eye, you see your opponent catching up to you. At moments like this, just 1 second can mean the difference between winning and losing. Units of time. The seconds is the SI unit used to measure time. Your heart beats once per second. When you are not running, that is. The second can easily be divided by multiples of 10, like the other SI units. For example, a millisecond is 1/1000th of a second. Longer periods of time are expressed in minutes or hours. There are 60 seconds in a minute and 60 minutes in an hour. Measuring time. Clocks and watches are used to measure time. Some clocks are more accurate than others. Some digital stopwatches, which are used to time races, can measure time accurately to 1/100th of a second. So how many milliseconds are in a second? I will give you a second to think about that. Pause if you need more time. A millisecond is 1/1000th of a second. Okay, you'll see here there are conversions here if you need help with that. Temperature. As you head out the door each morning, one of the first things you might notice is the temperature. Is it cold out this morning? How high will the temperature rise? Units of temperature. Scientists commonly use the Celsius temperature scale on the Celsius scale. Water freezes at 0 degrees C and boils at 100 degrees C. There are exactly 100 degrees between the freezing point and the boiling point of water. Normal human body temperature is about 37 degrees Celsius. In addition to the Celsius scale, scientists sometimes use another temperature scale called the Kelvin scale. In fact, the Kelvin scale, notice that, not Celsius, the Kelvin scale is the official SI unit for temperature. Units on the Kelvin scale are the same size as those on the Celsius scale. Figure 8 compares these two scales. 0 on the Kelvin scale, 0K, is the temperature the scientists consider to be the coldest possible temperature. Nothing gets colder than this temperature, called absolute zero. Absolute zero is equal to negative 273 degrees Celsius on the Celsius scale. The Kelvin scale is useful because it does not have negative numbers to complicate calculations. This is why scientists use the Kelvin scale. Measuring temperature. You can measure temperature using a thermometer. When you first place the thermometer in a substance, the liquid inside the thermometer will begin to move up or down. Wait until the level of the liquid stops changing, then read the number next to the top of the liquid in the thermometer. Converting between units. Okay, first of all, what is the official SI unit for temperature? It is the Kelvin. Converting between units. Did you ever have a jar where you kept all your pennies? Suppose you counted your penny collection and discovered that you had 236 pennies. How many dollars does that equal? With only a little thought, you could probably answer $2.36. Just like converting between dollars and cents, it is often necessary to convert one unit of measure to another. To convert one measurement to another, you need to know the appropriate conversion factor. A conversion factor is an equation that shows how two units of measurement are related. For conversion factors, refer to the conversion table included in this section. Okay, suppose you walk 1.5 kilometers to a friend's house. How many meters have you walked? To convert 1.5 kilometers to meters, follow these easy steps. First, begin to write down the measurement you want to convert. So we have 1.5 kilometers, and we want to know how many meters. Okay, find a conversion factor that relates to these two units. So we know that 1 kilometer equals 1,000 meters. Write the conversion factor as a fraction. Make sure to place the units you're converting in from the denominator. So notice how kilometers is on the bottom. Multiply the measurements you're converting from the fraction. When you do this, the units in the measurement will cancel out with the units in the denominator of the fraction. Your answer will then be in the units you're converting to. By converting between units, you now know that you've walked 1,500 meters to your friend's house. So 1.5 kilometers equals 1,500 meters. Okay? What is a conversion factor? It allows you to change the units by multiplying. Okay? So your homework for today is Section 1 assessment plus the math practice plus some of the other practice in the book. Okay? All right. Have a good afternoon, and I will talk to you guys again tomorrow.